This is Edward from Hong Kong Excel again. So welcome to my Math IA video here. And based on my teaching experience on 400 students worldwide, and I know that when IB students are asked to do their Math IA, or you can say math exploration, it will be always a very painful experience because the IB board asks you to write 6 to 12 pages, okay? So at most 12 pages on math. So it's it's a hard thing actually. So in this video, I want to solve all your problems, and I'll introduce you the structure and also give you a concrete example and also the Math IA model of how to score level 7. Okay, in your Math IA. Okay, so this video is for Math Studies, Math SL, and a Math Higher level. Okay, so basically for Math Studies, I'll introduce you the structure, and then you know what you have to fit in. Okay, so basically for Math Studies, we always use correlation and chi-square test. Okay, in your topic, okay, for the Math IA. But for Math SL, if you're only using correlation and chi-square test, okay, then that won't be enough. So I would suggest you to add more topics, okay, more other topics, okay, more other topics. But for a higher level, then you have to go a bit further, okay, you have to go for something that you still haven't learned, okay, or that is not in your syllabus. So not in the syllabus, okay. So that's the key point for the Math Higher level. So you have to add something that seems very hard, and then you have to fit it in your math investigation, and then you write an essay about that, okay? But first, I'll give you the structure of the Math IA. So I think all of you know that. So we have the 6 basic structures, okay? The 6 paragraph for the Math IA. So first of all, you have to show personal engagement, right? Okay, so this is just BS part, so bullshit part, right? So basically you can say, oh, I'm interested in some topic, so because of something, right? Okay, so but to be specific, you can actually talk about your activities, right? Okay, let's say you join what kind of society, right? And then also you read what kind of books, and maybe you can depends on your academic result, right? Okay, so you can say, oh, you're very good at math, or maybe a visual art, okay, something like that. So, and then you want to investigate a topic, okay. But in this video, I will suggest a topic that is called golden ratio. Golden ratio, okay. So, and I'll teach you how to use this topic, okay. This concept applies to studies, SL and higher level separately, okay, and how to write a good essay on that. So, and then the second part is explanation on the math theory, okay, math theory, and also the math equation. So whenever we use the equation, okay, we need to explain all the technical terms. So let's say maybe you write something like rational number, then you have to explain what does it mean by rational number. So it's the whole number over another whole number, right? Okay, so this is like the definition, okay? So you have to explain all the technical terms, okay? So, or maybe in Math Higher level, so we use Fibonacci sequence, okay? Fibonacci sequence, let's say, okay? So I'll explain it later for this one. So this is related to golden ratio. So this is out of the syllabus. But when you use these terms, Fibonacci, then you have to explain what does it mean, right? Okay, so and also maybe talk about the story about that, yeah. And then thirdly, so this is the calculation part. So this is very important. So that determines the major part of your Math IA. Okay, so calculation. So this one you have to avoid mistakes. Okay, you have to make sure all your calculation is right. Okay, and of course you have to apply the concept, right? So apply the calculation, apply the concept, and do the calculation, right? So in this part, you can make maybe tables, graph, okay, and also all your calculation steps. So show every single steps, okay, and then present and comment on the results. So when you get some results, right, when you get the numbers, okay, after a calculation, you have to explain what does it mean, okay. So explain the result, right? Okay, and this also counts a lot of marks, okay? So that depends on how well you interpret the results, right? Okay, and then limitation. So what does it mean by limitation? So limitation means that, oh, in your calculation, maybe your sample size is too small, so that will cause bias, right? So something like that. Okay. So or maybe you can say something on about the time. So the time limitation. So if you have more time, you should investigate more, okay, or you should hold the an interview longer, okay. So in order to get more in-depth conversation, and so you get more accurate data, right? So that is the limitation. And here I've already list out all the limitations that you can write. So it's here. So all the limitations. So time limitations, sample size, social structure. So let's say this. So in this video, I'm going to talk about the golden ratio. So maybe the beauty nowadays vs the beauty in the past. Okay, so they're not the same, right? Okay, when you compare different faces, then you can say, oh, maybe the social structure already changed. So that will affect our perception on the beauty, right? And also different countries. So different country, let's say in Asia, Asian countries and European countries. Okay, so the standard of beauty may be a bit different, right? Okay, so and also the use of data, first hand or second hand. So if that is first hand, then it takes time, right? Okay, but you have time limitation, or maybe sometimes you only ask your classmates, then it will cause bias as well, right? But for second-hand data, so let's say from a government report or some statistics from other company, okay, but that is not first-hand, so you cannot be sure that this data is specific to your investigation, right? Okay, so you can say something like that. And then, so finally, you have to write the reflection, so it means conclusion. So you have to conclude the results, okay, that you find. Oh, actually, there are some specific relation between something, okay? And then you have to write the conclusion, and that concludes the whole essay you're writing. So basically just a basic conclusion or reflection, okay, of the whole thing. So let's move on to these more technical and specific parts. So in this video, I'm going to talk about the golden ratio, right? So here, so all the soft copy in this video, you can go to the following links, okay? So I've already attached the link on the YouTube description, okay? So you can click there and then register, and then we'll send you the free copy of this, okay? So golden ratio, first of all, what does it mean by golden ratio, right? So golden ratio, so if you search online, then you have the number 1.618 something, right? Okay, so this is called the golden ratio. But the most important thing that this ratio measures on what? Measures on the length. Okay, measures on the length. So let's say if I give you a length from this one is A, this one is B, right? Okay, so this, you add up the total is A plus B, right? So golden ratio, the 1.618 is defined as, so this is the symbol of the golden ratio, okay, phi. So this is called phi is equal to A plus B over A, okay. So this ratio, okay, is the 1.618, okay. So this is called the golden ratio. The concept is a distance over another distance, okay, then you have 1.618. But how does this number apply to different phases, right, and apply to daily observations? So let's move on to this page. So you can see, so we assume that like a beautiful person, so a beautiful person, okay, it will follow the golden ratio. So her face, okay, will follow the golden ratio in this way. So this is a vertical proportion. So let's say this is a forehead, okay, and the nose, right, the corner of the nose here, okay, so this one is 1.618, okay, over this. So you can see the nose to the chin, okay. So here would be like the ratio, it will be 1.618 to 1. So what does it mean? Let's say if you measure the distance between the forehead and the nose, so let's say it's maybe 21 cm, okay, and then for here, nose to the chin, okay, so it's 13 cm, okay, so basically 21 over 13, 21 over 13, right, okay, so it will be very close to 1.618, right, so 1.615, okay, but in the golden ratio, then it will be exactly equal to 1.618, okay, so that is the meaning of golden ratio. And you can see, so the first pair, you can write it down, is the forehead, okay, to nose, okay, vs nose to chin ratio, okay, because after we do the calculation and I want you to get different faces, and you'll have to calculate based on these values, okay, and then for this one is nose to chin, right, okay. Oh wait, sorry. For this one is eyes, okay, to the mouth, vs mouth to the chin, okay. So right now you have two sets of data, right? And then for transverse proportion, okay, transverse proportion. And then for transverse proportion, so it means horizontal, right? Okay. So first you measure the distance of the nodes, okay, horizontally. So you have the distance here, and then you can compare with the mouth. So basically the distance. So first pair is distance, okay, of the mouth to the distance of the nose, right? Nose, I mean. Okay, so this one, so mouth over nose, then you will have 1.618 for golden ratio. And then what does it mean here, the eye distance? So from this side to this side, right? Okay, so it's 1.618 square. So for this one's a golden ratio square, and then for our head, okay, from this distance and this distance, it will be 1.618 power 3, okay? So basically, right now you have three sets of data. So this is for the distance between eyes, okay, and then for the head, right? Okay, and then finally external proportion. So you will have this. So if I draw a line from the ear to the chin and the top of the head, top to ear vs ears to chin, right? Okay, the ratio must also follow the golden ratio. Okay, so after you get the basic concept, like how to apply to different faces, and then right now you can go online and you can search like different faces, so that we consider maybe is beautiful person, or is like what we call ugly, right? So you can find as many faces as you want. So basically let's say I find three faces, A, B, C. So maybe a beautiful face, ugly face, and then like a so-so face, okay? So and then you have to do a calculation based on different faces. So how do you do that? So I have already made the table for you. Yeah, it's here. Okay, so for math studies, we'll focus on correlation and the chi-square test, okay, and math SL as well, but we just need to add one more extra concept in it. So first of all, step one, we calculate the difference. So let's say we consider vertical, transverse, and external proportion, okay? So deviation in A, deviation in B, deviation in C, what does it mean? So let's say after we do the measurement, okay? So for a vertical, so this one, the distance here, okay, then you measure distance between the forehead and the nose to the chin, right? Okay, so but after you get the value, oh, it's actually different from 1.618. So maybe the deviation, so this one is 1.6, okay, then you can say the deviation is 0.018, right? Okay, so this is less than that, right? Okay, so maybe you have a negative, so this one's less than the golden ratio by 0.018, right? Okay, if you get 1.628, okay, for another person or for another pair of comparison, okay, then this one you can say is 1.628 minus that, right? So then you have 0.01, okay, for the deviation. So for this table, I want to look at the deviation, okay, between the real face and golden ratio. Okay, so for positive, it means more than that. Negative, it means less than that. Okay, so for deviation A is 0.4, 0.02, 0.8. Okay, and for deviation B, so it's quite large. So it's 1 here. Okay, so vertical. So it means that this guy, okay, is like this is very large, and then this is very small. Okay, so it will be a very long faces for this one, and then 0.5 and negative 0.5. Okay, so this is just based on your calculation. Okay, so I just put a random number, but you understand the idea, right? Okay, so just use the ruler and then you calculate the ratio based on the diagram here. Okay, so for the deviation C, you can see this one has the least deviation, so 0.01, and then this one, and then 0.001, right? Okay, so basically what I want to find out is there any correlation between beautiful faces and the golden ratio? Okay, so my assumption is like if the deviation is very little, okay, then implies, okay, that person should be beautiful. Okay, so I want to see if my assumption is right. Yeah, okay, so basically we can add up all the deviation, but we only calculate the deviation, so it doesn't matter like it's negative or positive, so we just take the absolute value. Okay, we take the absolute value. So when I say absolute value, you can ignore the positive or negative. Okay, so I just want to see how much is the A face, okay, away from the golden ratio. So I add up all the difference. So 0.4 plus 0.02 plus 0.8, right? Okay. So of course, in your essay, you have to explain why we consider absolute, because we just want to see how much difference, okay, is away from the golden ratio, right? Yeah, okay, and then for deviation B, you just add up all this, then is 1.5, 1 plus 0.5 plus 0.5 is 2, yeah? And then finally, for this one, is 0.01 plus 0.02 plus 0.001, yeah? Okay, so you have 0.31. So the deviation is the least for this one, okay? And then I want to link to the real life, okay? So how can I link this data, right? So after my calculation, okay, I want to link this data to real life. So I interview 50 people on the comments on different faces and give the points. So let's say we have A, B, C different faces right now. Okay, so the point would be starting from 0 to 4, yeah? Okay, so I asked 50 people. So A person, A face, okay, 25 people give 1 mark, 25 people give 2 marks, right? So here is marks, and then this one is face, right? Okay, and then for B, 40 people give 0 marks, okay, and then for this one, 10, okay, just 1 mark, and then C, 3 marks for 1 people, and then 4 mark, 49 people, right? Okay, and here I want to calculate the average score, right? Okay, because we have too many data right here. So average score, how do you do that? So out of 50 people, so the average score of A, it will be, so you have to show steps how do you calculate this, right? So I'll just do one example. So 1 times 25 plus 2 times 25 over the total frequency is 50, right? Okay, so then you have 25 plus 50 divided by 50. So then you have 1.5 for the average score, okay? So after you get this data, you have to calculate the rest of it for the B and C. So for B, the score is quite low, is 0.2, and then for this one is 3.98, right? So after you do all the calculation, and then step 3, use the mathematic model, okay? So for this one, I choose correlation between the deviation and the average score. So I want to find out, is there any like correlation between the deviation? So if the deviation is very little, so it means that it's very close, the phase is very close to the golden ratio, okay? Then would it be like a higher average score, okay, for that phase, right? Okay, if little deviation, would it lead to higher score, right? Okay, I want to see, is there any correlation? Okay, correlation. So little deviation and higher score. Okay, so first of all, you need to know the equation of correlation. But what does it mean by correlation? Of course, you have to explain the terms. Okay, explain what does it mean by correlation. So in correlation, is actually talking about the relationship. Okay, relationship between two things. Okay, how much is correlated? And then we have positive and negative. Okay, if positive, it means that when x increase, y increase. So it's like going up the line. And then for negative, then it will be reverse. It will be going down. Okay, you have to explain briefly on the correlation. Okay, and then we have to use the equation. So what is the equation for the correlation? So the equation is a bit long. Okay, is here. So is n, and then summation xy, so you can copy this down, minus summation of x times summation of y over the square root, and then n times summation x squared minus summation x and then x squared, right? And then times, okay, it's very, very long, n and then summation of y squared minus summation y, and then you square it and then close the bracket, right? Okay. Oh, actually here is close the bracket and then square. Okay, so it's ey and then square. Yeah, so this, it seems like hard to understand this one, right? Okay, so basically right now I use the table here, then you understand. So A, B, C different phases, and the deviation is 1.222 and 0.031, right? Okay, and then for the average score is 1.5 for A, 0.2 for B, and then 3.98, right? Okay, so basically you have to calculate all the values and then fit in, right? So first is xy. So what does it mean by xy? So is this one and this one, right? You multiply the two. 1.22 times 1.5, and this one is 2 times 0.2, 0.031 times 3.98, right? And then for x squared, because here you can see we have summation of x squared, right? Okay, so then you have to calculate the x squared. So let's say this one's x, this one's y, right? So it's 1.22 squared, and then 2 squared, and then 0.031 squared, right? And for y is 1.5 squared, 0.2 squared, 3.98 squared. Okay, so you just do the calculation, and then what does it mean by the summation? So when I write summation, it means sum. Okay, so I have to add up the total. If I want to add up the total, so usually we write total of xy, right? If you want to avoid total of, okay, you want to avoid this word, then you can write in symbol is summation of xy. So I just add all this up, so it will be 1.22 times 1.5 plus 2 times 0.2, okay, and then plus 0.031 times 3.98. You get a number, okay, here, and that is the summation of exy, right? And then n stands for there are how many phases? So 1, 2, 3. So you have 3 phases, and then just sub all the number in. So summation of x, you know that. So we just add up all the x. Okay, we just find out the summation of x here. Okay, so I think you understand how to do the calculation here, and then I'll just give you the answer. So after you do the calculation, then the R, the correlation, is equal to negative 0.998. Okay, and then you have to. And then for this one, you have to explain the result later, right? Okay, so for this one is negatively, okay, correlated, and this one is negatively strong, right? It's very, very strong. Okay, so what does it mean? So it means that if I plot the graph, okay, if I plot the graph, right? So this is the points, and this is the deviation, right? Okay, so the least deviation, then it will we'll see the relationship between the points. It will usually have high points, right? Okay, and then for middle deviation, then you have the point here, okay, and then finally, if you have the highest deviation, the largest deviation, then obviously you will have lowest score, right? So then finally, you will see we have a line here. We can draw a straight line, okay? Then this one is called the scatter diagram, right? Okay, the scatter diagram, okay? So after you get the diagram, and then you can draw a line of best fit. So this is called the line of best fit, or you can say is the regression line, right? So of course you have to explain all this, and then so after you draw this, then you can explain why you can see there is actually a correlation between the deviation and the score, right? Okay, so how people measure the beauty, right? Okay, so this is how you do the calculation on the correlation. And then step 4, chi-square test. Okay, so chi-square test, so many students get confused between chi-square test and also the correlation. So they usually assume that, oh, if there is correlation, then something and something must be dependent events, okay, dependent events. So first of all, you need to understand what does it mean by dependency, okay? So when I say dependency, dependent events and independent events, right? So let's say you can think of the case that is independent events, like your school canteen, the food in your school canteen, okay? vs the teaching quality. So obviously, for if the food in your school canteen improve, it won't lead to better teaching quality, right? So this is not the cause. This is not the result of that. Okay, but there may be correlation. Okay, maybe coincidentally. Okay, so your food in canteen improves, and at the same time, teaching quality improves. Okay, so maybe there is a positive correlation. Okay, but this one is definitely not the cause of the teaching quality. Okay, so then you can say the chi-square test. Okay, chi-square test. We look at the causation. Okay, so cause and effect. It means cause and effect, right? And for dependent events, let's say income and your spending. So obviously your spending depends on your income, right? So if you have higher income, then that will lead to higher spending. Okay, so that is called dependent event. Spending depends on the income. So for the step 4, I want to see, is there any dependency on people opinion and deviation of the golden ratio? Okay, so let's say if we judge people, so do we base on the golden ratio, or we'll think of the golden ratio that is the main factor that will affect our opinion? So maybe yes, maybe not, right? So we want to see, is there any dependent situation between these two things? Okay, so then you have to do the calculation of the chi-square test value. So chi-square test value, so is here chi. Okay, chi-square test value. Okay, so you can write x squared. So chi is the Greek word for x. Okay, so chi-square test value. So I want to calculate this value, and then I want to have a conclusion on that, right? Okay, so you can actually use your GDC. Okay, so you can go to menu and the statistics, right? And then go to here and go to matrix. And this is obviously a 3 by 5 column table, right? So you just go 3 by 5, okay? And then you type in all the numbers here, and then you go to execute. So you execute the value, so that is, you calculate the value, that is 257, right? So, but what does this number mean? Okay, but another way of calculation of the chi-square test. Okay, you can go online and then you search the equation of the chi-square test. Okay, and then you apply that equation. Okay, so and you will calculate this value. Okay, so it's the same, but it will be better if you use the equation to calculate the chi-square test value instead of using GDC, because you can write more words, okay, on your IA. Okay, and then so after you get 257, we have to give the conclusion, right? Okay, so you have to compare with the distribution table, the chi-square test distribution table. Okay, the chi-square distribution, so which is like this. I've already printed out for you. Okay, so let's say we test test this thing on a 5% significance level. Okay, so what does it mean? So this one only tells you that the distribution, okay, for this part is 5%, 0.05, and then for this part is 0.95, okay? So just like this table, right? So if you use 10% significance level, okay, then you can choose this side, okay? So this line, so here will be more than 0.05, yeah? Okay, so basically right now I want to find out the standard of, so the critical value of this line, and then I want to compare if my chi-square test value is bigger or smaller than the critical value, okay? So first of all, you have to find out the critical value, right? Okay, so right now I have the information of 0.95 on a shaded area here, and then the degree of freedom. Okay, so V here means degree of freedom, but what does it mean? So it's very, very easy. R minus 1 times column minus 1. So R is the number of rows times the number of columns, okay? So number of rows, because we have a 3 by 5 table, right? Okay, so number of rows is 3, so we have 2 times 4, so degree of freedom is 8, yeah? So we have the value of 8 and also 0.95, then you have 15.5 as the critical value. Okay, so I know that obviously 257, the chi-square test, is on the right hand side of the critical value, is more than that, but what does that imply, right? So many students don't understand this part. So let me give you an analogy. So let's say if you're drunk, okay, and you drive the car, and suddenly a police, okay, just come in, right, and then he wants to test your alcohol level, okay. So let's say the critical value is the is a normal alcohol level. Okay, so let's say if you fit this standard or less than that, okay, you'll be okay, you'll be fine. Okay, if you are above the standard, then you'll be in trouble, right? Okay, so and then after testing, then you tell police that, oh, actually I'm not drunk, okay, but you have a level of 257, which is obviously way more than the standard. So what you said must be rejected, right? Okay, so the police would not trust you. So this one will reject, okay, what you said. Okay, so if within that, then we will always accept what you said, right? Okay, because what you said is acceptable. Okay, it's okay because you have proven that you're still conscious. You're still conscious right now. Okay, so and but what are we rejecting and what are we accepting, right? So in chi-square test value, the step one, we always assume the two things there are independent. Okay, they are independent. Assume two things are independent. Okay, so I assume that actually the deviation of the golden ratio and people's opinion on beauty, they are independent. Okay, so one does not cause another. Okay, but actually turns out that we reject this, so it means that we have to reject the independent assumption. So actually they are dependent. Okay, so and then you can lead the conclusion that is, oh, actually the golden ratio, okay, would lead to result in people's opinion on the beauty, right? Okay, so that's your conclusion. Yeah, so this is for the math studies level, and then you can finally, you know that after you explain the result, and then you have to write the limitation. But for math SL, obviously just writing the correlation and the chi-square test is not enough. So I would recommend you to add function topic, okay, quadratic. So actually the phi, okay, the golden ratio is defined as the length, one length over another length, right? So this is a, b, so it's a plus b over a, right? Okay, so if you do that, then you can divide a by a and then b over a. You can separate this, right? So that it will be 1 plus b over a. And after you get to this step, okay, so based on the definition, there's one more thing for phi, okay, so it's actually equal to, phi is actually equal to a over b. So this is the definition. So this is what the scientist or a mathematician find out, okay? So the definition of phi is a over b as well. So for b over a, you can actually write what? So this is the reverse of reciprocal, okay, of the phi, right? So this one you can say is 1 over a over b, yeah? Okay, so that is actually 1 over phi, yeah? Okay, but this whole thing is a plus b over a, right? So we're still talking about on the left-hand side is a plus b over a, right? So, and at the same time is equal to phi, right? Yeah? So you can write phi is equal to 1 plus 1 over phi, yeah? Okay, and then we simplify, we try to make it into a quadratic equation. So we both sides multiply by phi, is phi squared, right? And then for this one is you multiply in phi plus 1, okay? So rearrange the thing, then you will have phi squared minus phi minus 1, okay? So how do you calculate the value of phi? So it will be using the root equation, right? So x equals to minus b plus or minus square root b squared minus 4ac over 2a, right? Okay, so minus b is minus minus 1, it's just 1 plus or minus square root b squared, just 1 squared minus 4 times a is just 1 times minus 1, right? Over 2a, a is 1, yeah? Okay, finally, you have 1 plus or minus square root 4 plus 1 is 5, okay, over 2. So we have two values. One is 1 plus root 5 over 2 or 1 minus root 5 over 2, yeah? Okay, so, and then you just do the calculation. Actually, 1 plus root 5 and then divided by 2. So it's actually 1.618, okay, which is exactly equal to the golden ratio, right? But for another equation, 1 minus root 5 and then divided by 2. So that is equal to negative 0.618. Okay, so obviously we have to reject this one. Why? Because as I just mentioned, the golden ratio talks about the relationship, the length over another length. So length cannot be negative, okay? So we can only have positive values. So this one will be 1.618. So I would recommend you to add like half page on your calculation, and then you can say, oh, actually phi, the golden ratio, okay, the number is actually related to the quadratic equation, okay. And for a higher level, you can also mention this as well, okay. And then next page, it will be on a higher level. Okay, so for the higher level parts, so obviously by mentioning only correlation, the chi-square test and the function is not enough, okay, so you have to add something more, something extra, okay, so that is like out of the syllabus. So for this one, I'll suggest you to add Fibonacci sequence, okay, so how is that related to the golden ratio, okay, so actually Fibonacci sequence, if you search online, then you see it will first start with 1 and then 1 and then so the third number, it will be 1 plus 1 is 2, and then 1 plus 2 is 3, and then 2 plus 3 is 5, and then 5 plus 3 is 8, and so on, right? But how this sequence, okay, is related to the golden ratio, so you can actually see, so 2 over 1 here is 2, and then 3 over 2, what do you get? Is 1.5, right? And then 5 divided by 3, yeah? So 5 divided by 3, then you have 1.666. Okay, so it seems that, okay, it tends to be very, very close to the ratio, that is 1.618, right? Okay, so finally, so for this one, I've already found out all the Fibonacci sequence for you. So it's not all because it will go to infinity, but finally, when you get to this large, okay, this number, so you use this term divided by that, okay, so 149,352 divided by 9227465, and then you get exactly equal to 1.618. So 1.618, right? Okay, so you can see the pattern, the relationship between Fibonacci sequence and golden ratio, they are very, very close, okay? And after you get this relationship, okay, obviously it's not enough because this one will just like a few sentences, right? Okay, so you have to show the equation of Fibonacci sequence. So let's say for this case, I list out all the numbers for you, right? Okay, but actually you don't want to write all the numbers up, right? Because it's just too troublesome. So is there any faster way for us to find out the number of terms, right? Okay, so actually there's the equation of the Fibonacci sequence, okay, which is this. Phi, which is the 1.618, okay, power n minus this, power negative n, and then over root 5. Okay, so this equation helps you to calculate a specific term. So let's say I want to find out the third term. So we all know that the third term is 2, yeah? So if I don't use this sequence, okay, can I use the equation to calculate the third term, right? So you can do that. So just sub in the number 1.618, right? And then power of, so this one is the third term, so it's power of 3. And then minus brackets negative 1.618, okay? And then you close the brackets, power of negative 3, yeah? So, and then you enter, divided by root 5. Then you have the answer. That is very, very close to what? Is 2, yeah? 1.9998. It's because I use 1.618, so there's a rounding error, okay? So it should be actually exactly equal to 2, yeah? So basically, if I go like U100 and then U101 term, and then you use this one divided by that, then obviously you have a number very, very close to 1.618, very, very close to the phi, okay? Yeah, but whenever you use the equation, whatever new equation in the Math IA, okay, always remember you have to add proof, okay? So you have to show to the examiner, show to your teacher that you understand why this equation, how does this equation come from, okay? So actually the proof, I won't prove it here. I'll give you all the proof, the steps for the proof, and basically it's all about matrix, okay? Matrix. So we have to use the matrix to prove this equation, but actually the proof is 5-page long, okay? So if you want to prove, and this one also includes a story, okay, of the Fibonacci sequence. So actually Fibonacci sequence is found out by the rabbits, okay, so by like breeding trends of the rabbits. So first we have a pair of rabbits, right, and then so first month, okay, one pair, and then after that, after the second month, okay, so this young pairs becomes mature, right, okay, and then they will, after that, they will give birth to the second pair, okay, So the third month, then you have 2 pairs. Okay, so that's why 1, 1, and then 2, right, and so on. Yeah. Okay, so this is a young pair, and then after 1 month, so they become mature. So and then it takes 1 more month then for them to produce, okay, to reproduce a male and a female rabbit. So then you have 2 pairs right now, original and new pairs, right, and so on. So that's why it's 1, 1, 2, and then 3, and then so on. Yeah. Okay, so you have to explain the story and then explain how does this equation come from, and that already like occupies you a lot of pages. So this, you can see, is 5 pages long. Okay, so but this is very clear proof. Okay, so you can add this in your IA. And then finally, I would suggest you to add the golden spiral. Okay, golden spiral in your IA. So what does it mean by the golden spiral? Okay, so actually the shape will be like this, okay, and so on. But what does it mean? So you have to consider a square. Okay, this is 1, 1, 1, 1, right? Okay, so all is 1 here. Yeah. Okay, so and then so this 1, 1, I add this 2 up, then I can form the second square, right? So it's 2 and 2 here. Yeah. So and then after you get 2, then you can add up 1 plus 2, so you have 3, right? We have 3. Okay, so actually, if I draw the golden spiral, so here, starting from this point, and then to here, and then it will be going to here, and then go to here, right? Yeah, and then 3 plus 2, then you have 5. So it's 5. So you can see, yeah. So this one, okay, follows the golden ratio. So and then you keep adding the square, right? So you can see the spiral. So this one, the spiral is actually following the golden ratio. Why is it like that? Because when I draw the square, so this is 1, 1, right? Okay, and then I will have 2, 2, 2. Yeah, so 2. So it's just like 1, 1, and then 2. And then 2 plus 1, we have 3, right? And then 3 plus 2, we have 5. So you can see this is the fifth square. Okay, so and then keep moving on, then you can see you have a spiral. So this is called a golden spiral. But how does that relate to our beauty topic, right? Okay, so actually our human face, okay, okay, especially yeah, so when we're talking about the golden ratio, especially like the ears, so you can see we know that the ears is like this, right? So actually this, okay, also follows the golden ratio. Okay, also follows the golden ratio. Yeah, so you can say that, oh, actually the beauty, okay, and also the construction of human face, okay, is based on the golden ratio. Yeah, okay, and then you can compare. So based on previously we compared different faces, right? Okay, so we can see, oh, does this face match the golden ratio, right? Okay, so after you write all this, okay, and also the explanation, then your IA is done, right? Okay, and the last page here is the limitation. So I've just mentioned this in the first page already. So and finally you have to say that, oh, your IA, your investigation is actually there's time limitation, sample size, and the social structure change. Different country, different standard, right? And finally, first hand and second hand. Yeah. So this is all about the IA tricks. Okay, and also I hope this topic will help you to ace your IA. Okay. So if you have any question, then you can just email us, and I hope the video will help you to ace your Math IA. Okay, so if you need the soft copy of all the materials here in the video, then you can just click the link below, okay, in the description of the YouTube video. Okay, so we'll send you the free copy of that. And also, if you're if you're a standard level or a higher level students, okay, if you want a trial lesson on a specific topic overseas, okay, you can go to overseas.vnote.hk, okay, so to register math lesson, okay, or if you're interested in other subjects, okay, we also offer a free trial lesson as well. So no matter you're a local student or overseas students, okay, so you're all welcome. So for local student, if you want to come to our center, then you can just register here, and then we'll contact you later. Okay, so I'll see you next time, and I hope this video is helpful. And yeah.